Good morning, everyone. I'm Darryl Lee. I manage the ROS-Industrial Asia Pacific in Singapore. I apologize first that I couldn't be there with you guys today, but yeah, I'll try to do what I can from here in Singapore. So yeah, let me get started. So let me do a quick introduction about ROS-Industrial Asia Pacific. So we are part of the global consortium together with Siri and Fraunhofer. In Singapore, we are managed under ARTC, and we have around 18 members in the consortium with a good mix of end users, technological providers, Institute of Higher Learnings, as well as system integrators. Let me do a brief introduction about Advanced Remanufacturing Technological Center, ARTC. So we are a leading public-private partnership research center in Singapore. Our mission is to develop and deploy advanced manufacturing solution and upskill workforce to drive local industry competitiveness. So ARTC also work towards bridging the gap between research and the industry through co-creating, value capturing, and industry implementation. All right, in ROS-Industrial Asia Pacific, we have developed a few ROS2 packages where we focus on providing solutions for industry use cases. Two such ROS packages are namely EPD, which is the Easy Perception Deployment, and EMD, Easy Manipulation Deployment. So EPD is a ROS2 package that provides object vision capabilities that is easy to configure and deploy, mostly working on state-of-the-art machine learning algorithm. The key features are similar to the commercial available computer vision, includes the fast object detection, segmentation, localization, measurement, and tracking. So our recent updates where we saw we have Dockerized the exporter environment for accelerated model training to address frequent software dependency conflict. With this function, we see a reduction of setup time from 15 to 5 minutes on average. We have added the options for bash scripts for command line user, and we have also verified EPD to work with a couple of GPUs, namely the NVIDIA RTX 5000, GTX 1060, and Quadro M1200. So EPD is already released on the GitHub, which you can download through the QR code here. Next, I would like to do a quick sharing about a use case, an industry use case that deploy EPD. So our client is a health supplement company. They came to us with a challenge on manpower crunch and is keen to automate the sorting and packing of its powder sachets. So we use EPD. We integrated it with commercial available industry equipment such as real sense camera, Aglin IPCs, as well as ABB Delta Robot to automate this process. As this is the first use case for EPD, hence we do find quite a fair bit of effort required to resolve emergence bugs, such as accurate detections and orientation, etc. The significant outcome from this project is EPD utilizes open standard ONNX AI, which remove any over-reliance on any particular machine learning algorithm. And by using ROS, it allows our client to scale in future without lock-ins on any of the hardware. So we have helped them to fully automate the tedious operation and sorting of these sachets, reducing the overall manpower requirements from 16 to 2. And we target, right now this project is ongoing, so I think we should end around in 2 weeks' time, and we target to hit a cycle time of 0.8 pick per sachet. So I'd like to play a video here. And you could see that this is actually a powder sachet sitting on a moving conveyor, and the robot will identify with EPD. Through EPD, will identify the front-facing sachets, and pick them while leaving the back-facing sachets alone for recirculation. Right. The next package that we have in the ROS-Industrial AP, it's a manipulation, ROS-II manipulation package that provide fast and flexible pipeline for pick and place, and it can support a wide variety of grippers. Three key features here, it's the work cell builder. It comes with a grass planner and a grass executor. So our recent update is the inclusion of waypoint file loading to simplify the configuration in loading trajectory for specific tasks. We have converted the dynamic safety portion from the plugins from grass execution to controller node. And we have tested various collision elements with dynamic safety, and I will illustrate all this in the following slides. So for high mix pick and place, there are situations requiring object-specific trajectory depending on the required place position. So our team developed a waypoint file loading method for grass execution to easily configure and load trajectory-specific tasks depending on the grass object. This can help by scaling into different objects can be scaled with different configuration file. And it's especially useful for work cell area that require tight navigation, as well as it helps to stabilize the manipulator during execution. The JSON format-based configuration file provides easy to understand trajectory definition that can be configured and tweaked during the hardware testing. So if you look at the gift here, where you can see the cobot picking up the grass and place and flip them, it's following the action call out from the line command listed below. So it's kind of modular and easy to deploy. Next up, it's also to make dynamic safety more modular. We have converted the active safety plugins from the grass executor node to the robot driver node, allowing us to include or omit the dynamic safety functions on a per need basis. So this slide actually shows exactly how it becomes easier. On the left is actually the normal movie configuration file for any pick and place application needs. On the right itself, we included, just by including a few function call out, we could activate the dynamic safety. And here it's, we have tested the dynamic safety function, and it works under the three different scenarios. So the first up on the left is the robot can avoid another robot by reading the joint encoder. And the second one in the middle would be robot can avoid any collision object, measures and shapes created in MoveIt. And lastly, the robot can also avoid true perception sources such as automat and point clouds and 3D point clouds. I want to introduce an effort on an industry use case where they pinpoint on how to automate the packing and repacking of product by navigating through tight spaces in a delivering case. So this client, FMCG company, is looking for a fully automated solution, unpack, label, and pack commodities from and into a shipping case. We combine ROS-II, EMD, and EPD together with our industry partner to develop an end-to-end solution which can perform the above mentioned. We also created a shop floor control system that can orchestrate the hardware communication through PLC and MES systems. So challenge here is we found that we have significant error margin and inconsistent in ground truth detection, where we do acknowledge that EPD do have some optimization needed. However, we also found that the hardware that is available for ROS, it's kind of limited, with many of them do not support ROS. So that's kind of a limitation on the ROS platform. We also felt that further enhancement and stability on ROS2 platform would be required, as we understood that ROS2 stability has dependency on the quality of the drivers, adapters, documentation, version compatibility, and coding quality, so among many others. We found significant complexity in deploying ROS for industry implementation as compared to proprietary robotic solution. However, this is also the reason why we will continue to chase our vision to improve ROS features and reliability. And some of the outcome here is, as mentioned before, it helps the industry company to scale without lock-ins. It's able to, at the end of this project, actually, we have able to support up to 22 different products, each with its own unique configuration. And this system itself, it's modular, adaptable. And we hope to establish this solution to automate the entire production line and eventually have it ready for operation deployment in the future. I'd like to share two more other industry cases here. So we work with one of our members, Johnson & Johnson, through a project called bin picking. So the problem statement is Johnson & Johnson wants to automate the picking of their products from vertical lift module for mainly for the faster order fulfillment. With the use of ROS packages such as navigation, move it, and YOLO, we have managed to deliver and deploy this solution. So a couple of challenges. We found that navigation stack does has inherent inaccuracy, and we do have to have external vision system to correct the robot alignment. We also found that companies such as Johnson & Johnson has up to 10,000 SKUs. If they are like to onboard all their SKUs in the future, is going to take significant effort. So some of the project outcome is we managed to deliver a minimum viable product where it helps to increase around 35 to 65% improvement as compared to manual picking. Hence, it does satisfy the faster order fulfillment for J&J. And they do have full implementation plan for 2023. So let me run a video here. You could see here it's a simulation environment where the mobile manipulator is picking the product from the vertical lift module and put it onto the bin. Here up is the actual trials where the mobile manipulator will go on to do product scanning, identify, pick the one that it's required and load it onto the bin. And by using YOLO, an open source AI-based vision system, we have developed a solution that it's able to identify the items through reinforced learning and label them in the different colors, even though they do look very similar. Yeah. Okay. The last use case here is we have worked with Infineon Technology Asia Pacific, where they are looking for a robotic middleware framework RMF simulation to understand their production readiness needs if they are to embark on a fully autonomous manufacturing. So we have created the RMF fleet management simulation in Gazebo, and we have created a web user interface for task management and dashboard monitoring. We do have one challenge here. It's very typical for all simulation work that is assets. The CAD assets were not available not available, and the team had to build them from scratch. So one of a few project significant outcome is we have successfully developed this digital twin for Infineon factory shop floor, and this serves as their lighthouse in Singapore actually, and it serves as a platform study for scalability towards actual implementation in the future if they do go on for an autonomous manufacturing environment.
Hey, Darryl, just letting you know, 2-minute warning.
Sorry? Hello? Hello? Oh, okay. Yeah, I will speed up. So, yeah, okay. On ROS training, we concluded 2 training sections on ROS-II navigation and easy robotic manipulation in the month of April. And in order to facilitate the members from regional countries, we have delivered the training via Zoom and Amazon EC2 instances. So the training section has an exclusive class ratios of 1 trainer to 4 trainees. This is part of our effort on proliferation of ROS, where we don't just work with companies on projects. We look to train keen developers to enhance their ROS skills and also to help young engineers to adopt ROS. And this is going to be my last slide. We have upcoming trainings on ROS-II as well in the month of August and in September. So do reach out to us if you're keen to attend, and thank you everyone for your time on this. Any questions?
Afraid we won't really have time for questions, Darryl, but
yeah, okay.
I totally get it, but yeah, it was just a little hard to tell you, give you advance notice on the time, but thank you. And obviously feel free to ping Darryl via email and everything. He's pretty accessible, or you can always reach out to me or Christoph. We can always get messages around. But Darryl, thank you for staying up late in Singapore, as always.
Yes.
Being flexible at the time.
Thank you.